do want to hold off on R4 and R5 and wait for those to do those last. But let's go ahead and do the rest of the resistors. So, okay, and here we have another typo. So C1 for capacitor, then C3 for the resistor beside it. So I'm going to go ahead and bend my resistor leads again, so they're all ready to go. So now we've got all the resistors and capacitors on our board except for a few. So we held off on R4 and R5, which are the big 1 gig ohm resistors, and also C2 and CF. And the reason we held off on those is because they connect to these little turrets, these little brass holes. And that's also where some other wires are going to connect later on. And so it's best to hold off on doing those until last. We have to fit into those big holes a couple of leads. So in this one, actually on the left side, 3 leads. So one from CF, one from R4, and one from C2. And that's fairly hard to do. So it's worth leaving to last. So I'm going to start off by putting R4 and R5 in. They look like this. And these are the resistors that you can't, if you lose them, you can't buy them in town. And they're actually very hard to find because they're a value that's only used mostly for microphones. So don't lose these. All the other components you'll be able to find and buy in town if you need to, if you lose them. I will not have spares for you. You will have to go find them if you lose them. So R4 and R5 are in, and then CF, which is this one. And then C2. And whichever one you put in last, CF or C2, is going to be difficult to get in. Sorry, I just bumped the camera. Just wiggle it a little bit if it's hard to get in. And try and get all these down as far as possible so there's very little lead sticking up. That's how the resistors will look. You don't have to get them any flatter than that. And then we'll solder these. Now, because of the number of leads in these 2 holes and the big metal rings around them, which help with conductivity, it's going to be harder to solder. So you're just going to have to put more heat on it, leave the iron on for longer. And even though we're going to add some other wires to those connections, I think it's best to go ahead and solder them now. And then I'll show you how to add the wires when we get to that point. So now we're going to go ahead and do our transistors. D2 says G2 on the board. And there's a line marking which direction the transistor should go. Again, try and push it down close to the board. You won't get all the way, but as close as you can is good. On the board layout sheet, it also gives you a really good drawing of how that transistor should be. And then D1, so if you look on the board, D1 is listed, but there are only 2 holes for it, the 2 outside holes. So you have to take the middle lead, which is the gate, because this is a JFET, and bend it like it's kicking. And then put those 2 leads that are going down into the holes for D2, push it down in place, and then the gate comes up and touches where R5 and C2 connect. You can bend that over a little bit if you want, and we'll solder that right there. And then cut off your leads, and you're ready to go. Now we're on to our last 2 components, our 2 transistors, D1 and D2. So down here you'll see it says G2, that should say D2, and then up here you have D1. This sheet that didn't come in your mic box but is available on Canvas is really helpful because it lists where all the components go and also gives you a better picture of the transistors and how they're going to connect. So we'll start with D2 at the bottom. So you can't really tell from the PC board, although there is a flat line. From this picture you can tell how it should be oriented. So it just goes straight across these holes with the flat side facing up. And then D1, which is the main transistor, the FET, if you look at the drawing here, you see there are 2 leads connected, the outer 2 leads, but it doesn't show the center one. If you look at the picture on Canvas, you can see that what's been done is this center lead is bent out, and then it connects to the same place where R5 and C2 connect. So as odd as it seems, that's what we're going to do. We're going to solder that. It may seem like a bad solder way to do this, and if you want, you can try sticking it through the hole with the other 2 leads, but I find that difficult, and this is what I find works best. And this will work fine. So now we'll solder those. So I'm trying to get this where you can see what I'm doing. Just want to get everything hot. So I'll make sure it's not going to come off nice, and that's a good connection. Now I'll go ahead and cut off my leads. Now here, we'll see a little problem. So these two leads, the solder on them is actually connected together. And I'll say that I was, what actually happened here for me, because that's a really unusual thing for me to do. I've been soldering for so long. I just had it too far away trying to get a good camera angle. So that'll be my excuse. But watch out for those, because those are really easy to do. They're called solder bridges. So make sure that solders aren't connecting together. And I find that when I'm cutting the leads is when I often notice those. So take time when you're cutting the leads to look at all of your solders. Okay, both PC boards ready to go now. This sheet's going to be incredibly useful for the rest of the bits we're going to do. So we're going to start off with this connection that's shown here, and it's really the only place you see it. There's a plus and minus marked on this PC board that has fewer components on it, right up here at the top. And if you take one of the leads you clipped off of a component after you soldered it and bend it, got all our components on. Now we're going to start connecting wires to the PC boards and the transformer and the XLR. This sheet is going to be really helpful for all of this. This is the one that's in Canvas. So here on this PC board that has fewer components, you'll see there's a plus and minus and a connection between those two. That's the only place where you really see that that is supposed to happen. And here it is on the printed circuit board itself. So I've got one of the leads I cut off of my components as I was building the circuit. I'm just going to bend that and put it in those two holes so the plus and minus are connected. I'm not sure why that's there. It must have been that there's some slight variation on this kit where they have those going different places and not connected directly together. I don't exactly know. So I'm just going to lay it down on this vise and solder those. Now then we have all the wires that connect to things. So there are these A and B points where the two circuit boards connect together. Then there are the pad switches and capsule connections. And those are all pretty easily understood. If you look at the microphone, we want to find blue/green from the capsule. So here's this blue wire from the capsule. Red from the capsule, which looks a bit more orange to me. And then 2 from the pad. And these 2 white ones are the pad. And you can see that those go up to where the pad switch is. And then we have two red wires from the filter switch. And the red wires from the filter switch are not shown very clearly here. But down here, it says roll off. So those are those two red wires. And the pad are the two white wires. And then we have an orange and blue wire coming with the capsule, and then this black wire that comes, that's ground for the whole capsule area. And then down at the bottom, you'll see the wires going to the XLR and to the transformer. The problem with those is that the colors are not quite right. The colors that we have here are not the same as what are on this sheet. And there's no indication here of which of these go to the transformer, which of them go to the XLR. So here's how we'll figure that out. There are a couple things we could do. We could take this all apart. So these 3 screws and these screws come off, and this will all come apart. We can see the transformer inside. We can see the XLR. So that would be one option. But we can do it a little easier. We can simply measure with our meter and see where the connections to the XLR are. So setting my meter for continuity. I'm going to clamp this mic in this vise just so I can do this while talking to you, videotaping. So I'm just going to touch, so I have this set to continuity. And I'm just going to touch each pin of the XLR and then the wires. So I'm going to start off with pin 1, which is over here. So I'm touching pin 1 with one of the leads. And then, according to this sheet, the XLR should be white, black, and red. So we'll try, there are 2 whites, not that one. Okay, so that is pin 1 of the XLR. Please don't drop your microphone. They're pretty sturdy, so you don't have to be too gentle with them. Don't throw them around, but if they fall, it's not that big of a deal. So we want a way to mark all of these as being on the XLR or the transformer. A little piece of tape would be nice, but once you build it, the tape won't be able to stay in there because it'll be too big. So what I'm going to do is simply take a marker and put a black mark on all the wires that are from the XLR. And I'm going to write this down. So on my sheet, I'm going to write that white XLR is pin 1. Because they say white XLR is pin 3. And then I'll go to pin 2 of the XLR. And that's the blue wire. And again, the sheet that we have doesn't say anything about a blue wire coming from the XLR, so. And then pin 2. So that's orange. So not at all what it should be. So pin 2 is orange. So I'm going to fix these down here now. So XLR2 is orange. XLR3 is blue. And XLR1 is white. Now, I will warn you that you need to do the same process, because historically these have not been the same colors for all of the kits we get. Hopefully they'll be better this year since we bought them all at once, but no guarantees. So go through this process and make sure you know where your wires go. So now we have wires going to the transformer. So 2 wires here and 2 wires here. 2 wires on the primary, 2 wires on the secondary. And this is showing that it should be black and green on the side that connects to R11, 13, 14, and 12. So that's this side. The secondary should be black and green, and the primary then should be white and red. So we'll see if that's true. Still using continuity, we can test and see if black and green are connected together. And we have a black and a green, and we haven't used those for the XLR yet, so that's a good sign. So there is a connection. That means that is a coil of wire. That's 2 ends of a coil of a wire. So those are right. Black and green are correct. So then the others should be red and white. And we do have a red and a white left that we're not using yet. So there's the white we marked for the XLR. So that these two should be connected. And they are, so it's not a low enough resistance that we're getting a beep, but you see it does say 140 ohms, so that is a connection. So that means that red and white for the transformer on this side are correct. So now we know what all our wires do, and we can simply solder them to the PC board.